Okay, now we will be talking about simple example just to make sure that we make connections between the probability and the area under the curve. Suppose that we have, again, let's go back to the exam. You are given an exam in statistics and the average score for that class, suppose the class contains 30 students, and the average score was 70. I'm using mu because we are talking about the population, and the standard deviation was 5. And you are told that the distribution is a symmetric or bell-shaped. So immediately what you do is just look at the distribution. The distribution of the grades is a bell-shaped. So immediately what you say that the mean is in the middle. Now, the way that we are going to assign the probability is going to be different now. From now on then, the way that we are going to assign the probability is going to be different. We are going to graph, we are going to make charts, and we are going to make connections between, we are going to use the idea of the area under the curve. So the very big idea from chapter 6 and chapter 7, 8, 9, we have to know that the area under the curve is the same as the probability. Okay? The second point, so the area under the curve, the second point that you have to be aware of is the area under the curve is 100%, which is 1. I'm talking about this area. Is 100%. Okay? The third point you must understand, you must know. In this chart, in every chart, every curve you sketch, you see, you will have two values. No, I mean, okay, I don't mean two specific values. I mean two set of values. The first set is going to be the values on this axis, on the x-axis. And these values represent your data. Okay? Two set of values. Number one is the x-axis values, which is your data now. The second set is going to be what? The associated probabilities. Where can we find the associated probabilities? What do you mean associated to what? Associated to the x-axis values. Because each value we will assign a probability to it, right? Where are we going to find that one? So this is going to be the area under the curve. So this is the third point. Now, let's go back to the example. So the area under the curve is 100%. The mean is in the middle. That means, technically, it's clear that 50% of the area is the right-hand side. 50% of the area on the left-hand side of the mean. This is perfect. This is clear. Now, suppose that I ask you a question. Now, we will be asking now questions about probabilities. What is the probability that a person will score less than 70 in the class? Again, because this is continuous probability distribution, you will never use the equal sign. Use less than or greater than. So what is the chance that a person is going to score less than 70%? Immediately the answer is going to be 50%, 0.5. Because you look at the area under the curve. What are you asking? The question asks what? The question asks the chance that x, what is x? X, all of the values belongs here. What is the value that this x is going to be less than 70? So we are asking about all of x's in the left. What is the chance that someone in the class scored less than 70? So you're going to look at the left-hand side of the mean. Why the mean? Because 70 is located here. So the answer is going to be 50%. If someone asks, what is the probability that x is going to be greater than someone scored greater than 70? Again, the answer is going to be 50% because we're going to look at the right-hand side. X is greater than 70 here. And what is the probability when x is greater than 70 is 50%. Again, if someone asks you, what is the probability that x is less than 50 or 20%? Someone scored less than 20. Where is the 20? You have to locate the 20. You have to tell me, oh, 20 is somewhere here. So what is the probability that x is less than 20? Which is here, basically. What is the area in this region? What is the area? You have to ask your question, what is the area? I can tell you the area here is 0. Why? How did I know? I used the empirical rules. Do you know the empirical rules? Do you remember this one? Because we know one standard deviation, we're going to have 68% of the data. So 68% of the data, they're going to be within one standard deviation of the mean. So 65, between 75, you have 68%. And we know that 99% of the data they're going to be within 3 standard deviation. So I know for sure that most of the data, they're going to be between 55 and 85. So anything below 55, almost the probability is going to be 0. Anything greater than 85, the probability is going to be 0. So that's why now, if you ask me, the probability is going to be 0. But actually, we will not use this in intuition. We'll be using some formulas right now. But I'm trying to explain the idea of make connections between two things, the x and the probabilities. And if I ask you what is the probability that x is greater than 90, what is the chance that a person scores greater than 90 in that exam? Again, using the empirical rule, you can tell me the answer is going to be 0. Where to see this probability? You're going to see it. We have 70 here, 75, 80, 85, 90, somewhere here. So you're looking for this portion. What is the area here? The question asks you greater than, look, the question asks you greater than 90, x greater than 90. So you look at the 90 first, then you go to the right because it's greater than 90, then you look at the area. What's the area associated to the 90? Or to the right-hand side of the 90 is actually the area 0 here, almost. Okay, so this is the idea of the area under the curve, and as I said, we have to make connections between two things, x and the associated probability.